session on fluid mechanics. In this session, we will start with the next topic, that is pressure and its measurement. We will first discuss what is fluid pressure at a point. We need to understand the term pressure or intensity of pressure. We indicate this by small p. This is nothing but a small force acting on a small area. So say there is a small area, I call this as dA. There is a force acting perpendicularly on it, that is dF. So this force acting perpendicularly on the area, and you need to understand that there is a difference between the term dF and delta F. When I say it is d, I am talking about ordinary differential equation of mathematics. When I say the term delta, I am talking about partial differential equation. There is a clear difference between the two. Suppose if I write this in the form of delta, then these two terms, that is force with respect to area, when I am differentiating, I cannot segregate these two terms. They cannot be separated. But if I have to separate them, then I will have to use the term d over here. So when I write ordinary differential equation, these two terms can be separated. That means I can take this as P into dA is equal to dF. But if this is delta, then these two cannot be segregated. Now, suppose if I say that pressure is equal to delta F by delta A. Say if you can write in this form, that is also possible. Differentiation in the form of partial means it is partially differentiating with respect to a particular parameter. It can also differentiate with respect to another parameter. That is what is called as partial differential equation. Ordinary differential equation means that here force is a function of area only. It is not a function of any other term. But had it been partial, it means it is partial changing with respect to area or any other parameter, say length or something. So accordingly it is changing, but here we have only one parameter change, so I can write this as d, and hence I have separated these two terms. Now when I say that this pressure, that is a force, so when I say that this dF, which is nothing but the pressure force, when it is acting perpendicularly on a particular area, and it is a small one, but I can integrate for a bigger area A, and that time I can say that this is F acting on area. You can integrate this on both sides, that is P integration of dA is equal to integration of dF. So this becomes P into A is equal to F, or I can say pressure is equal to force upon area. So this force is called as pressure force, as I told you, and this is nothing but the cross section area. This is very important. Now there are various units of this pressure. So if I have to write in the form of MKS unit, this will be kgf per meter square or kgf per centimeter square. Suppose if I write in the form of SI units, this will be Newton per meter square or Newton per centimeter square. Now Newton per meter square in itself is called as Pascal. This can be written as PA. There is another unit system which we have is FPS, foot pound second system, where pressure is indicated in PSI. This is another most common way of indicating pressure when you are talking about pressure measuring instruments. There you will find pressure mentioned in form of PSI and not these units. So PSI is pound per inch square or pound per square inch, whichever way you want to say it. Now if you have to go for conversions, The first conversion that you need to know is 1 Newton per meter square is nothing but 1 Pascal. 1 kilopascal, or I can say this is 1 kilonewton per meter square, is nothing but 10 raised to 3 Newton per meter square. Kilo to Newton is 10 raised to 3. Then if I talk about 1 megapascal, this will be 10 raised to 6 Newton per meter square, or this is nothing but 10 raised to 6 Pascal, because Newton per meter square is Pascal. Then if I talk about gigapascal, this is another important way, that is 10 raised to 9 Pascal. When I say 1 terapascal, this is 10 raised to 12 pascals. Also, another important unit is 1 bar. Bar is an important unit of pressure which is used in pressure measuring instruments. So 1 bar is 10 raised to 5 Newton per meter square, or we can say it is 10 raised to 5 Pascal. So this is all about the concept of fluid pressure at a point. So here you can see that we are talking about a particular area. A point means some small cross-section area where we are talking about, and we want to measure the pressure, so you can use this formula P is equal to F upon A, where F stands for pressure force and A stands for cross-sectional area. So with this, I end the session. I hope you have understood this lecture. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.